Hello students, welcome to new video. In this video, we'll discuss about the DC generator practice questions. Let us see the first question. DC generator operates on the principle of. We know that DC generator works on the principle of electromagnetic induction. Electromagnetic induction means whenever conductor cuts the flux, EMF will be induced in the conductor. Let us see the second question. DC generator working is based on the principle of dynamically induced EMF. Dynamically induced EMF means EMF is induced in the rotating conductor. So armature windings are placed on the rotor. So whenever armature is rotating armature conductors cuts the flux. EMF is induced in the rotating armature conductors. It is dynamically induced EMF. Third question. The mechanical energy source used to drive a DC generator is called. So we know for DC generator, input is mechanical energy, that is rotation. So who will provide that rotation? The thing that provides the rotation is known as prime mover, which provides the movement or rotation. Next, fourth question. The the generator develops electric pressure by, again same DC generator, electromagnetic induction. Fifth question. An electric dash is a machine which converts mechanical energy or power into electrical energy. Mechanical energy rotation into electrical energy voltage, that is known as generator. Generator converts mechanical energy into electrical energy. Which type of core coupling occurs between mechanical and electrical system? It is electromechanical coupling system. Next question. High permeability magnetic material helps. High permeability means which produces more flux. So to confine the flux within the magnetic circuit, to allow the flux to leak, to produce a more current. So it helps us to confine the flux within the magnetic circuit. For iron, the curve flux linkage, for the iron, the curve between the flux linkage and current. So for iron, the up to certain point, as the current increases, flux is going to increase. But after certain point, the iron gets saturated. There is no development of the flux. So it's not linear, but it is not circular also. EMF induced in each conductor of a DC machine. We already discussed, whenever armature conductor cuts the flux, EMF is induced in the armature conductor, that is alternating EMF, AC EMF. But this AC EMF is converted into DC with the help of commutator. So, but initially in the each conductor of the armature, the EMF induced is alternating EMF. Answer is A. In DC generator, the initial voltage is produced. We have discussed in self-excited DC generator, initially in the field winding, due to residual magnetism, we will be having some residual flux. Whenever armature conductor cuts that residual flux, we will be getting residual voltage. So due to this residual magnetism only, the generator is going to build up its voltage. In a DC generator, the EMF is induced in the armature coils. So EMF will be induced in the armature coils. So field coil nothing but they produce a flux. So correct answer is armature. What these commutator segments will do? Commutator will convert AC into DC, and brushes will collect the brushes are used to collect the output current from the rotating part or give the input current to the rotating part. EMF is induced in the armature coil. Which of the following is a function of the yoke? See, yoke has two functions. One function is it acts as a protecting cover, and one more function is it also provides the return path for the flux. DC generator generates DC voltage in the armature, AC voltage in the armature terminals. AC superimposed over DC. As all we know, AC voltage is induced in the armature coils or armature terminals. So answer is B. EMF generated in the armature terminals of the DC generator is proportional to what? In the theory concepts, I forgot to discuss this. EMF induced in the armature conductor formula, EZ is equal to pi Z N by 60 into P by A. This is called EMF equation of DC generator. So EMF induced in the DC generator directly proportional to the number of poles. Yes, P is directly proportional to the number of poles. Directly proportional to the flux per pole. Yes, here flux per pole is there. Eg directly proportional to the flux per pole. Directly proportional to the number of conductors per path. So here Z by A. This Z by A is number of conductors per path. So EMF depends upon all the A, B, C three things. The answer is D. Very important equation, EZ is equal to pi Zn by 60 into P by A, where this A is number of parallel path. A is number of parallel paths. That means how the armature conductors are connected. So there are two types of windings, lap winding and wave winding. For lap winding, number of parallel paths A is equal to P. For wave winding, number of parallel paths A is equal to 2. Next, in a multipolar p-pole machine running at n rpm, the frequency of the generated EMF. See, we have one formula, n is equal to 120 f by p. So from this, Pn is equal to 120 f. So from this, f is equal to Pn divided by 120. So Np1 by 120 or Pn by 120. Answer is D. Next, the induced voltage in a simple loop reverses. It comes from the working principle of DC generator. It reverses once in each half revolution. Next, slip rings are usually made up of some conducting material, that is copper. Slip rings purpose is to collect the current from the rotating part. Slip rings also known as what? Commutator. Slip rings also known as commutator. The armature current in the DC machine is collected by brushes with the help of commutator. The armature core of a DC machine, is made up of, it should be laminated and it should be laminated steel. The function of the brushes in DC generator is to carry current to the external circuit. Convert AC into DC, that will be done by the commutator. It provides a path for the current into the external circuit. It collects the current from the commutator segments and it will give a path to the external circuit. The commutator in a DC machine, it converts AC into DC in the DC generator. It converts DC into AC in the DC motor. So as it is mentioned, DC machine means it may be generator or it may be motor. So both A and B are correct. So answer is C. It may convert AC into DC, it may convert DC into AC. Next, in a DC machine, the number of commutator segment is equal to the number of coils. In DC generator, lap winding is used for. So we have discussed there are two types of winding, lap winding and wave winding. In wave winding, all the conductors are divided into two parallel paths. So this is wave winding. So total current I will be divided into two parts. This is wave winding And in lap winding, number of parallel paths is equal to P number of poles. So in wave winding, total current is divided into only two parts. So whereas in lap winding, total number of current is divided into many paths. So this lap winding can accommodate high current also. So lap winding is used for high current. As the number of parallel paths are more, in each parallel path number of conductors becomes less. As the number of conductors are less, the voltage induced in the each path will be less. So less voltage. So lap winding, what is a lap winding property? Lap winding will give us less voltage and high current. Lap winding will give us less voltage and high current. If I take wave winding only two parallel paths are there. So only two parallel paths are there means high current is divided into only two paths. So it cannot accommodate high current. Therefore wave winding low current. And as total number of conductors are divided into only two parallel paths, each parallel path will contain more number of conductors. More number of conductors means more voltage, so it will give us more voltage. Wave winding is low current, more voltage. Lap winding is less voltage and high current. So here it is asked for lap winding. So high current we have to check. So this is high current, but less voltage, this is not correct. So high current and low voltage. So answer is what? B. High current and low voltage. The material for commutator brushes is, so again brushes are also made up of some conducting material, that is carbon. In a DC generator, the generated EMF is directly proportional to the, already we have discussed EMF in the generator is equal to pi Zn by 60 into P by A. So it is directly proportional to the pole flux. So pi is the flux per pole. So it is not directly proportional to the parallel path, it is inversely proportional to the parallel path. So the answer is pole flux pi. Which of the following is not a part of a DC machine? Armature is part of the DC machine, commutator is also there, field winding is also there. Damper winding will not be there in the DC machine, it is used in the synchronous machine to reduce the vibrations, to improve the stability. So answer is D. Commutator segments of a DC machine are made up of copper. Wave winding is suitable for, wave winding will give us more voltage and it can accommodate more voltage and less current. So dash current, less current, and dash voltage, more voltage. So answer is B. Low current and more voltage. The number of armature parallel path in a simplex lap winding. So in case of simplex lap winding, number of parallel paths A is equal to what? P. So how many pole generator it is? 12 pole generator. So 12 pole means A is equal to P, that P is equal to what? 12. Answer is 12. If we increase the field current of a DC generator, then its EMF output. So EMF in the DC generator is equal to pi Zn by 60 into P by A. So EMF is directly proportional to what? Flux. But we know flux is directly proportional to the field current. So as the field current increases, what is going to happen? Flux is going to increase. Field current increases, flux is going to increase. So as the flux increases, EMF is going to increase. But let us say if I take field current on the x-axis, flux on the y-axis, up to certain point the field current is going to increase and accordingly flux is going to increase. After some point, even the field current is increasing but flux is going to not increase. This is called magnetic saturation. So if we increase the field current of a DC generator, its EMF output increases indefinitely. No, after some point flux is constant, EMF is also constant. Increases till winding burns. No, increases till the magnetic saturation. This is the correct answer. Correct answer is what? C. In a DC shunt generator, already we have discussed, shunt generator field winding resistance is high when compared to the armature. So field winding resistance is high when compared to the armature. Answer is A. The residual magnetism of a DC shunt generator can be regained. So due to the residual flux, this residual magnetism, armature conductors are cutting the residual flux, then we are getting some EMF, and that will cause some current through the field winding. Further flux increases and further voltage increases. This will build up the voltage in the DC generator. But let us say if the residual magnetism is not there, residual flux is not there, then what we have to do? Residual magnetism we have to regain. How can we do? A, connected by the shunt field to the battery, running the generator on no load for some time, grounding the shunt field, reversing the direction of the rotation of the generator. So we have to give some power supply to the shunt field winding. Therefore, we have to connect a some battery to the shunt field winding so that some flux gets developed in the field winding. So answer is connecting a shunt field to the battery. Next, let us see one small problem here. A 6-pole lap winding generator. So P is equal to 6 and lap winding. Lap winding means number of parallel paths A is equal to P, and it has 300 conductors. Number of conductors Z is equal to 300. The EMF induced per conductor. So EMF induced per the conductor EG is equal to 5 volts. EMF induced by the conductor means EG by Z is equal to 5 volts. The generated voltage of the generator. So we have to find total voltage generator we have to find. So here as the winding is lap winding, so in lap winding number of parallel paths A is equals to what? P. So P is equal to how many number of poles? 6 poles. So total conductors are divided into 6 parallel paths, 4, 5 and 6. So total how many conductors are there? 300 conductors. So 300 conductors should be divided into how many parallel paths? 6 parallel paths. So in each parallel path, how many conductors will be there? 300 by 6, that is 50. So in each parallel path 50 conductors are there. Here 50, here 50, and every parallel path contains how many conductors? 50 conductors. So voltage induced in one parallel path, voltage induced in one parallel path is equal to total conductors 50 into, in each conductor how much voltage is induced? In each conductor 5 volts. So 50 into 5, that is 250 volts. So generated EMF generated in the one parallel path is equal to 250 volts. Answer is D. The field of self-excited generator is excited by, in case of self-excited generator, the field winding power supply is given by its own current. The voltage of DC shunt generator is built up by permanent magnetism, proper operation of the field rheostat, residual magnetism, increasing the speed. So because of the residual flux only, the self-excited generator or shunt generator is going to build up the voltage. DC shunt generator gives its greatest voltage at no load. In a separately excited DC generator, the field is connected to separately some source, to an external source. So in separately excited DC generator, this field winding is connected to separate source, and this is the armature winding. Armature output is not connected to the field winding, not connected, and this is nothing but what, load. So in case of separately excited DC generator, field winding is connected to some separate external source. In shunt generator, the voltage buildup is generally restricted by saturation of the iron. When the iron is saturated, then flux is not going to be developed. Flux is not going to develop further, and EMF will not be induced further. In long shunt compound generator, the shunt field is connected in parallel with the in long shunt compound generator like this. This is shunt field winding, and this is series field winding, and here it is armature winding. So this shunt field winding is parallel with both the series field winding as well as armature winding. Shunt field winding is in parallel with the series field winding and armature winding. Shunt field winding is parallel with the series combination of armature and series field winding. So answer is D. Shunt field winding is in parallel with the series combination of armature winding and series field winding. Next, the field winding of a DC shunt machine usually carries very less current, that is 2% to 5%. The shunt field winding resistance is more so that it can carry only less current, and more current should flow through the load. So only 2% to 5%. And next, a DC series generator has a terminal voltage of 110 volts. So terminal voltage of 110 volts. Terminal voltage means V is equal to 110 volts. The armature resistance is 0.2 ohm. RA is equal to 0.2 ohm, and current is 10 ampere. So and current is 10 ampere means their meaning is armature current is equal to 10 ampere. The generated EMF is how much? So generated EMF we need to calculate. So in case of DC series generator, the EMF induced in the generator EC is equals to, what is the formula? IA EC is equal to V plus IA into RA plus RAC. Here armature resistance is given, but field winding resistance also we need. So this might be its resistance means it becomes RA plus RAC. So terminal voltage is how much? 110 volts plus armature current or field current both are same, that is 10 into RA plus RAC is what? 0.2. So 10 into 0.22, that is 112 volts. A DC generator is developing no load voltage of 220 volts at a rated speed of 1500 rpm. So voltage V is 220 volts at the rated speed is what? 1500 rpm. If the field flux is reduced with the remaining conditions are unaltered, it will develop what? Now the field flux is reduced. So we know EMF induced at the generator is directly proportional to the flux. Field flux reduces means obviously the EMF is going to reduce. So it would be less than 220 volts. Answer is B. Next, the terminal voltage of the dash generator widely changes in the load current. So in case of series generator, the terminal voltage is going to widely change because EG is equals to, what is the formula? V plus IA into RA plus RAC. So terminal voltage V is equal to EG minus IA into RA plus RAC. So this is the terminal voltage of which generator? Series generator. In case of series generator, the load current is equal to armature current. So as the load changes, IA changes. IA changes means total terminal voltage is going to change widely. So in case of series generator, the change in the terminal voltage is wide. A 4-pole lap wound DC machine. So 4-pole lap wound DC machine means number of parallel paths A is equal to P. The magnitude of the generated voltage when the machine is wave wound. So 4 pole DC machine, when the winding is lap winding, the voltage is 110 volts. Then the magnitude of the generated voltage, let us say this is VP, when let us say it is V1, will call V1. When the connected winding is lap winding, V1 is 110 volts. And when the winding is changed to wave winding, and what is the voltage value? See, in case of EMF generated EG, in case of DC, EG is equal to pi Zn by 60 into P by A. So nothing is changing, only the type of connection is changing, therefore only parallel paths are going to change. So Eg proportional to 1 by A. So here Eg2 by Eg1 is equal to A1 by A2. So we want Eg2 by Eg1 is equal to 110 volts. So that is equal to A1 means lap type of winding. Lap type of winding means number of parallel paths A is equal to P, that is equal to 4. And wave winding means 2. So Eg2 is equal to, this becomes to 210, that is 220 volts. In a DC machine, the iron loss is also called as core losses. The greatest percentage of heat loss in the DC machine is due to copper losses. Copper losses are more, so copper losses will produce more heat. Stray losses in the DC generator. Stray loss in the DC generator consist of dash and dash losses. So magnetic losses and mechanical losses are known as stray losses. The maximum eddy current loss occurs in dash of a DC machine. In case in which part of the DC machine the maximum eddy current loss are happening, as armature core is rotating in the magnetic field, in the armature core only maximum eddy current losses are going to happen. Next, an ideal DC generator has regulation of dash percentage. For ideal generator, the voltage regulation is 0. Which loss in the DC generator varies with the load? Eddy current losses are constant, hysteresis losses are constant, windage losses are also constant. Only copper losses will vary with the load. Next, in DC generator, critical field resistance refer to the resistance of which winding? Critical field resistance is going to refer about the field winding. The terminal voltage of the dash generator widely changes with the load current. Already we have seen series generator. Now let us see some previous year questions on the DC generator. DC generator can be considered as, it's not a rectifier, it's not a prime mover, it's not a power pump. We can treat this as a rotating amplifier, as it develops it converts as less mechanical energy into more electrical energy. As it is amplifying, we can say it is a rotating amplifier. The direction of the EMF induced in the DC generator can found by Fleming right hand rule. In motor we use Fleming left hand rule. In generator, EMF induced in the conductor is used. EMF induced in the conductor direction can be found out using Fleming right hand rule. In an induced voltage in a single loop reverses once in each half revolution. The yoke of a large machine is invariable, made up of fabricated steel because of its high permeability. sorry, pole of a DC machine is laminated for the purpose of, so lamination usually done to decrease the eddy current losses. Next, the function or functions of pole shoes in a DC machine is to support the pole coils, yes, to reduce the reluctance of the magnetic path, and to spread out the flux onto the armature conductors through the uniform air gap. So all the options are correct. For both lap and wave winding, there are as many commutator bars as the number of armature conductors. Thank you. These are the some practice questions on the DC generators. In the next video, we'll discuss about the DC motor concept and practice questions on the DC motors.